Good morning. Uh, mm, he- the, Now we are going to discuss about digital logic and microprocessor combinational circuits. In combinational circuits, we are going to discuss about BCD to 7 segment decoder. So BCD to 7 segment decoder in digital electronics. So first one, that is a binary coded decimal. So what is meant by BCD? So BCD is the binary coded decimal. So BCD is encoding scheme each of decimal numbers. So 0 to 9 is represented by its equivalent binary pattern, which is generally 4 bits. So here the BCD numbers can be limited to up to 9 only, 0 to 9 only, and it is 4 bit binary values. And what is meant by 7 segment display means that is 7 segment display is a electronic device which consists of 7 light emitting diodes. So light emitting diodes arranged in some definite pattern. So in definite pattern there is common cathode and or common anode type. So which is used to display hexadecimal numerals in the case of decimal numbers, as input is BCD. So that is 0 to 9. So we are going to performing the number operations, numeral operations 0, 1, 2 up to 9 in LED. So we are using the 7 segment display on 7 segment display unit. So it can be classified into based on common cathode or common anode type. So using the BCD decoder method. Next one, there is two types of 7 segment LED displays is there. First one, there is common cathode type. In this type of display, all the cathodes of 7 LEDs are connected together to the ground or VCC minus VCC. Hence, common cathode, and LED displays digits when some high signal is supplied to the individual anodes. So this is common cathode type. And in common anode type, that is in this type of display, all the anodes of 7 LEDs are connected to the battery or plus VCC. So in common cathode type, that is connected to the ground or minus VCC. In common anode type, it is all the LEDs are connected to the battery or plus VCC. And LED displays digits when some low signals is supplied to the individual cathodes. So this is the main two types of the 7 segment LED display, common cathode and common anode type. But in 7 segment display does not work by directly supplying voltage to different segments of LED. So here the performance can be by using BCD converters. So first one, our decimal is converted to its BCD equivalent signal, then the BCD to 7 segment decoder and converts that signal to the form which is fed to the 7 segment display. So in this method, first so it is directly it cannot be directly accessed. The decimal number can be first converted into the BCD equivalent, and then BCD equivalent is converted to decoder 7 segment decoder value, and then converted to the signals. So that is fed into the 7 segment display. This BCD to 7 segment decoder has 4 input lines. So there is 4 input lines, that is ABCD, and 7 output lines. So here we are decoder is, that is we are using 4 cross, that is 4 input lines, and we are getting 7 output lines. So what does 7 output means? That we are assuming that the displays as A, B, C, D, E, F and G. So this can performing the number operations. So based on the switching on of A and B, like that, so the 7 segment display operations can be performed. This output is given to the 7 segment LED display, which displays the decimal number depending upon its input. So what are the inputs? For example, ABCD value 0000, and we are accessing the A values and B values like that. So based on the 4 input values, what are all the binary values we are giving, it can performing the output based on the given input values. So this is a general BCD to 7 segment converter decoder. First one, applying in the input we are applying, that is ABCD. So we are applying the ABCD input that can be converted into the BCD format. So in BCD format, and after that it can be converted to A, B, C, D, E, F, G. So there is 7 segment LED display. So based on the operations, the LED can be displayed and the number can be shown in the display of the LED. Next one, this is the truth table for common cathode type BCD to 7 segment decoder. For example, ABCD. So that is the value we are giving, that input is 0000. The value ABC up to F, the value is 1, and G is 0. So based on this number, the number can be based on this, the number can be displayed. So for example, all the values are 1. So all the values can be 1, the numbers can be displayed, and the values of values 1001. So this is up to 9 only. So here we are using the BCD decoder. So we are performing up to 9 values, and remaining after 9, the 10 to 15 values are invalid in the BCD values, invalid. So that is not considering here. And for example, last 9, so we are going to display the number 9. 1001 is the values A and D is given as 1, and B and C the values is given as 0. So by applying this input A, B, C, D, can be that LED only switched on, and FG LED can be switched on. The 0 LED cannot be switched on here. So that performs that displays the number 9. Likewise 1000. So we are applying the input A is 1 and remaining terms is 0. So all the displays can be performed. So for the number 8, all A, B, C, D, E, F, G, so all the number can be 1. So all the number can be displayed. So that is based on the input, the operations can be performed. And note that for common anode, the anode type 7 segment LED display, we only have to interchange all zeros and ones in the output side. For A, B, C, D, E, F and G, replace all 1 by 0 and vice versa, and using K-map. So we are going to solve K-map for each and every values of the A to F values. Output is first combination of the input, that is ABCD in the truth table, corresponds to 0, and last combination corresponds to 9. Similarly, rest corresponds from 2 to 8 from top to bottom, and BCD numbers only range from 0 to 9. So and the remaining 10 to F's are invalid inputs. So this is the example for applying 1 0. So applying, that is a 4 input, the 4 input ABCD. For first example 9, that is 1 is applied to A and D, and remaining B and C we are applying 0. So this is the binary value we are applying as the input, and the output we can perform this 9. Likewise the 1 and 0, the 1 is applied to B and C, and 0 is applied to A and D, we are giving the output as 6. Likewise 0 and 1 can be, and all the LED digits can be performed by using these operations. And for combinations, so this is I explained. And applications, so what are the applications here is, that is computerized clocks. So BCD to 7 segment decoders are utilized in advanced tickets to zone time in hours, minutes and seconds by changing over the paired time information into decimal digits. And it also can be applicable for counters and clocks. In counters and clocks, these decoders drive 7 portions presentations to show the count value or pause time, making them fundamental in different counting and timing gadgets. So these are the different applications, and adding machines, computerized meters, so and different applications and different mathematical digits in mathematical operations. So the BCD to 7 segment display can be used here. And the disadvantages, what are the disadvantages? The diminished port count. So this limits the quantity of ports expected to control a 7 portion show, and further developer dependability gives a strong and solid change from BCD to show portions, and simplicity of mix. So that is smooths out the methods involved with incorporating mathematical presentations into advanced frameworks. So these are also the advantages. And disadvantages is cost for straightforward applications and speed limits and size imperatives. So these are the disadvantages in using 7 segment displays. So utilizing a dedicated decoder IC may be more costly than less complex answers for essential necessities. And speed limits, so it is handling speed is very less and inadmissible for fast applications. The actual size of the decoder IC may not fit in the minimized plans. So these are all the disadvantages. And try to answer these questions. What is meant by BCD code? How many input lines are required for BCD to 7 segment decoder? How many output lines are there in 7 segment display? Differentiate between common anode and common cathode 7 segment displays. Which logic levels are used to turn on the segments in common anode display? And which logic levels are used to turn on the segments in common cathode display? Write the truth table for BCD input 0000, and what will be displayed when the BCD input is 0101. State the function of BCD to 7 segment decoder IC. Name any two commonly used BCD 7 segment decoder IC. So these are the questions. Try to answer these questions. Hope you are all understanding. Thank you.